Titrimetry, volumetric methods. Titrimetric methods of analysis. Some of the oldest classical weight methods. High accuracy and precision. Analyte reacts with solution of known composition. Applicable to a wide variety of analytes. Originally manual, now automated. Titration. The control addition of a measured volume of reagent of exactly known concentration to a known volume of a solution of analyte which concentration is unknown. Requirements: known reaction stoichiometry, rapid reaction, no side reactions, large change in some solution property at equivalence point. Consequences of equivalence and influence quantitative reaction. Standards in Titrimetry Primary Standards. Materials that can be weighed out exactly. Secondary standards standardize against primary standards. Standard solutions made of approximately then standardize. Requirements of primary standard: highest purity, high molecular formula weight, stable to dying, readily available and cheaply, not deliquescent, phenomenon of a substances absorbing so much moisture from the air that it ultimately dissolves in it to form a solution, are hygroscopic types of titrimetric methods and oceanographic applications. Acid-base alkalinity, precipitation, chloride, chlorinity. Complexometric Ca plus Mg plus Sr, redox, Winkler, Do. General helpful hints: need to know modality and normality, concept of equivalence. All reactions occur on an equivalent basis. Use factor level system in all equations and calculations. Review an analytical chemistry text if necessary. Normality equivalence. Concentration based on idea that all substances react on an equivalency basis. Definition of an equivalent dependent on the type of reaction. Acid base reacts with 1 mole of protons. Precipitation 1 mole of univalent ion. Redox 1 mole of electrons. Complexometric 1 mole of substances forming complex. Normality of a solution is the equivalent per liter. Examples of normality: as NO3, as plus NO3 minus 1 mole is equals to 1 normality. S2SO4, 2S plus SO4 minus minus. KMNO4 must have defined the reaction, that means how many electrons involved in the redox. MnO4 minus aqueous plus 8S plus 5E minus. Mn2 plus 4H2O. MnO4 plus H4H plus 3 minus MnO2S plus 2H2O. AgNO3 plus NaCl gives AgCl plus NaNO3. AgNO3 plus K2Cr2O7, Ag2Cr2O7 plus 2KNO3. Equivalent weight. Mass in grams of one equivalent of a substance equals molecular formula weight divided by equivalence per mole. Equivalent weight may be less, equal to, or greater. Latter is rare than molecular formula weight. Volumetric relationships. For any reaction at equivalence V1, N1 is equal to V2, and this is the basic of all calculations. For titrations we adapt. V standard and standard is equal to V unknown and unknown. Acid-base titrations. Plot pH versus volume of titrant phase added. Near equivalence pH changes rapidly with small addition of phase. Equivalence point at pH is equal to 7. In point should be nearest as possible to equivalence point. Weak acid base titrations. This is the graph pH versus ml of the NaOH. Strong acid, strong base. Plot pH versus volume of the titrant base added. Note slope of the pH change in first half of titration. Have situation when part of titration curve involves a buffer. Equivalence point of pH is greater than 7. Effect of Ka on titration. Strength of acid impact titration curve. Weaker acids, more difficult buffer effect. Hard to see in point as most indicators are weak. Acid species too. In points, the flag that goes up to indicate that equivalence has been reached should coincide with the equivalence point, usually triggered by a relatively large change in a property of the solution. Change in pH of solution, DEMF, or the current flow in a solution. Refractive index changes, usually enhanced by use of an indicator. Types of indicators: acid base, weak acid base, organic dyes, precipitation, other ion that forms insoluble substances with titrant. Complexometric, other substances that forms complex with titrant and is called redox, other substances that undergoes redox reaction with titrant or use electrometric detection. Phenolphthalein, weak organic acid C20H14O4, used as an acid base indicator. Colorless in acid, pinkish in blue base. Transition occurs around pH 9. Does not dissolve very well in water. Usually prepared in alcohol solution. Transitions of phenolphthalein acid-base titrations involved cleavage of ring, dissociation of two OH groups, then hydroxylation. Activates triggers chromophore phenolphthalein in point. Weak acid base transition near pH 9. Adiochrome black tea 3-hydroxy 1-hydroxy naphthalene azo 7-nitro 1-naphthalene sulfonic acid Na complexes Mg double plus pink. When all free Mg double plus has been titrated, Mg double plus EBT complex dissociates to allow formation of stronger Mg double plus EDTA complex. Free EBT indicator is light flow. Reaction of halides with Ag plus AgNO3 plus NaCl gives AgCl plus Na plus NO3. Base of more method for detain of this chlorine in seawater. Cl is equals to Cl minus plus Br minus plus I minus. Use standardized solution of AgNO3 as titrant. Dissolve halides from insoluble compounds with Ag plus. Reactions are quantitative because of low Ksp of AgCl 1.82 multiplied 10 to the power minus 10. AgVr 5.2 multiplied 10 to the power minus 13. NAgI 8.3 multiplied 10 to the power minus 17. More titration. Visual is K2Cr27 K2CrO4 indicator forms brown Ag2CrO4 precipitate. Accuracy and precision is nearly equals to 0.5%. Includes Cl minus 558 mm in standard CO2. Br minus 0.86 in mm in standard CO2 and I minus at most 0.2 mu m in standard CO2. In extreme cases, Br minus and I minus can raise to 2 mm. Each determination of Cl minus should be corrected from Br minus and I minus. On a practical basis, the corrections will always be less than 1% or approximately twice the level of accuracy achievable by this method. More titration with AgNO3 using the is preferred analytical method for Cl, unless equivalent but slightly more precise. More titration with electrometric is used. Electrometric if we uses Ag plus ISE if we detected on the basis of equivalent point, detected on the basis of the Ag half reaction, Ag plus E minus Ag 0. Electronic equivalent point 0.1% accuracy and precision. Silver ion electrode Ag plus 1 E minus Ag 0 E is equals to E naught minus 0.059 per n log products for reactants. E is equals to E naught minus 0.059 log 1 by Ag plus is equals to E naught plus 0.059 log Ag plus. Upon addition of excess AgNO3, it raises sharply. Complexometric titration derived from inorganic chemistry basis is sharing of electron pair between metal and the ligand. Complex formation ligand or ligands is R electron rich species. Complex formation is a multi-step process. NiS2O4 2 plus Cl minus gives NiCl4 2 minus plus 4S2O. Stepwise completion. Ni2 plus Cl minus NiCl plus NiCl plus Cl minus NiCl2. NaCl2 plus Cl minus NaCl3 minus NaCl3 minus plus Cl minus NaCl4 minus. Each step is described by a Kf. Overall K is product of individual Kf's. Beta 1 is equals to K1, beta 2 is equals to K1, K2, beta 3, K1, K2, K3, V4, K1, K2, K3, K4. Complexometric titration based on the complexion of analyte with large multi-dentate molecule rather than stepwise complexion with individual ligands. Common functional groups that solve as individual ligands are E-rich, carboxylic acids, amines, imides, thiosulfate. Stability of chelates. Complexes of multidentate ligands are more stable due to the chelate effect. Rings with 5 or 6-fold complexion are best. Entropy effect enhance stability. MS2O6 plus 6L ML6 plus S2O7 is equals to say MS2O6 plus L gives Ml plus 6S2O2 7. Greater entropy change for the later reaction. Electron pair sharing amino polycarboxylic acids. EDTA, ethylene-diamine tetraacetic acid, has 6 Lewis base sites, 4 oxygen and 2 amine electron pairs. It is often designed as 4Y and its anion is Y4 minus. All 6 complexion sites are able to bind to a single metal ion for many metals. EDTA. hexadentate complex domain groups, four-acetate groups, very strong case with most metal ions, high plus valency ions, binding constant I of pH, changes in EDTA situation as pH, formation constant with EDTA. Now you can see the formation. Ca and Mg titration with EDTA, Cd titration with EDTA.